This is Scott from KIG. It's about April 25th, give or take, 2017. We are in our back area, our small chiller test area, where today we are going to test this Riedel, or do a runoff of this Riedel, approximately 2 1/4, 2.5 ton air-cooled chiller. We have several of these, 10 or 11 different sizes of these Riedel surplus never used chillers. This one's a model WKS 51.2 M5LS.I 2KS C 05100299662 serial number. It's a 2015 unit with R134A refrigerant. This unit, and as we're talking, let's turn off our heater here. This unit is a 460 volt 3-phase. Now these units, and we've done this many times, were originally set up for a laser machine and for 2 circuits, where the main circuit, which is run by this controller, controls the laser circuit. This circuit here is what they call an optic circuit, which is about 10% or 5% of the water flow of the whole unit. What we do is we basically disable this whole circuit here because we don't need it for 99% of the applications that our customers use these for. So what that means is the unit does just have one brazed plate heat exchanger. It has one primary process pump. That's the one we'll be using. But it also has a secondary smaller pump there, a modulating or 3-position valve, and what they did is they would steal a little bit of the process water from the primary flow for this secondary circuit. That secondary circuit is simply those smaller fittings you see right there. So all we do, and this is approved and common by Riedel, we called them in Kalamazoo, Michigan. We just simply have these internal shutoffs in the off position here, and we have the contactor for pump number 2 disconnected inside the controls, and that basically disables this whole second circuit, and the unit runs as one single circuit chiller. We have a Danfoss compressor or Manurup compressor here. It comes out to about 2.25 horsepower, give or take. Our brazed plate heat exchanger, a nice stainless tank, and these nice Grundfos pumps. These are phase dependent as far as rotation goes. The Grundfos pumps are a little bit different than what some people might be accustomed to. Their rotation, when you look from the rear, you can see that. Their rotation is actually counterclockwise as opposed to clockwise. So when you first put power to this unit, and you're probably going to want to snake power up through here and then up into the control enclosure. When you first put power to the unit, get a helper here with a flashlight, and you're simply just going to toggle this quickly, the power on. Now right now I cheated. I have the disconnect power on here, so typically you want the power off if the cabinet is open. That's all you're going to do to check the phase rotation. Okay? If it's not rotating correctly, do not change anything other than 2 of the 3 main incoming power leads that you see here on your main disconnect. And obviously before doing that, you want to disconnect the power at your main breaker. In our case, it's a disconnect on the wall over there. So obvious stuff. This unit was set up originally to have the ability of a remote on-off start. We've jumpered that, and we've actually added in this simple on-off switch. Okay, so we are going to turn the unit on. When that happens, the controller just kind of goes into a little stall mode just for a second. Then you can see it comes up to show what the temperature of the process setting is. This you'll never see on for the application this is going to be used for. So this has a temperature rating, a low of about 12 C, which I think is what, 52 Fahrenheit or so. And for this application, that's fine. And you're not going to have to really get into any of your settings here, F1, F2, and so forth. There is a incredibly hefty manual that comes with the chiller. Some of it's in German. You just have to sort through to get to the English section. The main relevant part you'll need, and you probably won't even need it if you watch this video, is in the back of the book on page 24. Just going over what some of the functions are in the controller. Now, it's a little bit backwards than what some people might be used to. You have here E1, E2, E3, E4. When all those lights are on, that basically means everything is operating correct. Okay? E1 is your pump and water level status. That's normal. E2, high pressure. So when the light's on, that means it's behaving correctly. When it's off, that means there's a problem related to the high pressure refrigerant alarm. E3, low pressure, and E4, TK or fan status. That will go off if there's an error related to the fan, or if the compressor shuts down, because that's related to the fan too. Then we have here 1, 2, and 3. 1, the red light will be on when the pump is on. 2 will be on when the compressor is on and cooling. 3 in this case is actually not used, and I made a comment here in the manual relating to that. So then the only other thing, after you check phase rotation, okay, and obviously get the unit piped up, and I'll talk about a couple other things in a minute, is you have to change the set point, it's up and down, okay, but you have to hold the set point in while pressing the other button. So we're going to hold the set point in, okay, and we're just going to bring it down to the coldest it can go, 12 C. So you can hear the fan turned on. Now it has fan cycling. I'm sorry, not the fan, the compressor turned on. It has fan cycling, so the fan doesn't necessarily have to be running when the compressor is on. Okay. These are your internal shutoffs, so it already has shutoffs in the unit. You don't have to add them external. And this here is your bypass between supply and return for your primary circuit. This one here is for the smaller circuit, which is not even going to be used. You can see we got a little bit of nice healthy flow in the tank there. We obviously have the side cover for this unit. It's never been used. In this case here, the side covers don't have to be on while you're running the chiller. You should. But because the condenser is all self-contained in this assembly here, we're getting airflow over the condenser even with the side covers off. Some units require side covers on when they have a slab condenser that takes up the whole side of the chiller. We have a pump pressure gauge. It's in bar, but you're not going to see any pressure for what they call the optic circuit. We're just going to be using the laser circuit here. And this warning light here, water deficiency, I think they call it, that's just if the tank level goes down. There's actually 2 float switches in the tank, here and here. It's kind of nice. Usually we just see one. They just want to make sure it's in that happy medium. This modulating valve, even though the light is on, that's how it was going to steal some of the cooling for the secondary circuit. Even though that light's on, it's not functional, and we don't need to worry about that. So related to this bypass, it's already preset, so you get enough flow over the exchanger. If your restriction on your process is too much, there's a small chance, depending when we cook this up, we might have to adjust that. But I'd first just try starting it up just the way it is. The differential in here is built into the controller. This will come down to about 12C. It'll probably go 0.6 degrees centigrade below set point. The compressor will shut off. There'll be some residual cooling. And then the compressor will turn back on when it's 0.6 degrees C above set point. So I'll come back to video number 2 in a second as we reach that set point.